find on this, well, I'll try and get this to work, is that unfortunately on the board, because of the way I scanned it, it's not in any particular order. So I'll go through some questions to help you out, okay? And what would help you is to look at it closely as we go through. All right. Well, the questions are in order, but the pages aren't. Oh, okay. They're back to front of that one. Okay, so let's have a look. You have a question here, and usually it's, when you look at these questions, you're always going to be looking for the verb on it. So explain is the verb in this case, and you explain how an optic fibre transmits light. Okay. And
I didn't know what an optic fibre was.
Yeah, so the first question I'm looking at is question 25. And the reason I'm doing this, guys, is because this is the order it's scanned in on, not because it's the order in your paper. It's worth 2 marks. So it probably means you're going to be talking about 2 things, okay? The first thing it's going to talk about is that the fact that light refracts.
Or maybe what an optic fibre is.
Second thing that you might mention is it works on total internal reflection. The word reflection does not count in it as a way you do it. And the other thing you could mention is you could mention the fact of different optical densities.
Optical fibre is a bit of glass, and that transmits like it's basically how you get it.
Yeah. So that's the, if you remember, it's the thing I came out with where I had those very fine strands of plastic and glass, and I put I started off actually by having a bottle with a hole in it and water pouring out, and I put the laser through it, and the light went down the water, and then, no, I have shown you this, guys, with this, yeah.
I haven't seen it.
Okay.
What are we called? Optic fibre. Yeah, we talked about optic fibre and World Communicates. We didn't do the crack.
Oh, okay. So we talked about how it worked, and we did a page on it. Yeah, sorry.
Actually, no, we did do total internal reflection because we got the circular mirrors and we shined a light beam and we watched it go through it.
That's right. Yeah.
So we did.
Yeah. So that's what that was about. Look, so what they're really looking for 2 facts. The optic fibre is glass with different density to the coating around the outside. That would have gotten you a mark around about. If you mention total internal reflection, that's going to help you. And if you mention the fact that it uses refraction, and even if you describe what refraction was, that's going to help you there. The next one, guys, it was really, really important that you actually just, it's only 1 mark, and it just asks you to identify on the board here. The square looking wave is digital because it's either on or off essentially, and the wavy looking thing is the analog. And you're supposed to refer to the diagram above about how digitising works. Now, what you will notice on the board is that midway between the lines there, yeah, come in. Coordinating. Okay. Yeah, I've been doing. So, what you'll notice with the digital data, you can see that there's a place where sampling takes place, which is in between these units. And so what it does is essentially, as you would have realised, it looks for average points for the analog wave, and then it just makes a straight line signal, which is the average of the analog for that between those 2 sample points. So you had to mention something about sample points, and you had to mention something about averaging the analog data. Yeah. Now, the next part over here, guys.
Can you actually explain
what we had to write?
Because, guys, I'm actually not going to go through and argue my marking scheme with people. So I'm just trying to give you hints here. Well, it's probably to do with the coherence with which you mentioned it or the way in which you put it together, because I marked according to the standard that has to be there. Now, inertia, everyone got that pretty much right in question 17. Part B, everyone pretty much got that right. But you notice that they're one, you notice the 1 mark there. The thing about 1 mark questions is that they are easy. You actually have to get very small, a very small part of the whole thing right to get the whole mark. Now, the thing about the inertia question is there are multiple ways you could have answered that. Some people referred to Newton's first law. Some people referred to the fact that it means that it's, yeah. It's not a type of movement, it's a description of how things continue to move. Okay. This question. This one we got stuck on, before we get to that. Okay, question 18 here.
Yeah.
Right, we'll need to move through this one and do the maths for you guys. Now, the best way to learn this stuff, guys, is very simply be listening in and watching. If you discuss with people who get it wrong, all you're going to do is teach each other how you got it wrong, not the right way. Okay? Very, very simple. Now, the first thing you're always going to do in a question like this, of course, is you're going to draw a couple of diagrams, aren't you guys? Because that's going to help you understand. Now, the diagrams can be anywhere on the page, it doesn't matter. I'm just being silent because the people I really want to hear these are having their own little chat. So the first, you've got 2 situations. You've got a beginning situation where you've got 2 cars, which they call car X and car Y. And then you've got a final situation. In the beginning one, this car is 6 kilograms and it's moving in that direction with a speed of 0.25 metres per second, right? Which I've drawn very badly up there. This car here, which they call Y, is a mass of 4 kilograms. So they're pretty big toy cars, I have to say. And it is moving at 0.5 metres per second. After a collision occurs, car X is travelling in the opposite direction at 0.06 metres per second, it says. And it's still 6 kilograms, and car Y, which is still 4 kilograms, is travelling that direction with some velocity we don't know. So that's my diagram there. Okay, the next thing that you know is that the momentum at the start must equal the momentum when you finish. All right, that's a statement we've said many, many times, momentum's conserved. So the first thing I want to do here is I want to work out the momentum that I know. So momentum initial is going to be the mass of car X with the initial speed of car X, or the initial velocity, plus the mass of car Y times the initial velocity of that one. That's the equation to work that one out. I put all that in and I'm going to end up with 6 times 0.25 plus 4 times minus, y minus, opposite direction, 0.5. And if I work that out, that's going to be 1.5 minus 2, isn't it? Which means that my total momentum in the system is minus 0.5 kilograms meters seconds minus 1. Okay, happy with that? So now I can work out my momentum final. Now the momentum final is going to equal the minus 0.5. I know that because the momentum at the start and the end must be the same. Yeah. The momentum for this system is going to be constant throughout the whole thing. Okay, now, what you're going to do next, worry about this, then worry about marks. This is going to be m x vx plus my vy, right? We know that, which is going to be, please don't talk in the background because this is important to you guys as it is for anyone else. Now that's going to be 6 times minus 0.06 plus 4 times vy.
That's the speed of it.
It's there in the question. Okay? So that means that, and I'll have to go up here and just scribble over this side, and this would be legitimate in an exam. They're quite happy if you do this. So I can now go 0.5 equals 6 times minus 0.06, which is 0.36 plus 4 times Vx. And if you rearrange all that, and I'm not going to go through all the rearranging the maths for you, you can just do that in a calculator, what you end up with is 0.035 metres per second. Now, if you got the formulas in there and you got the wrong numbers in it, you're going to get a mark for doing that because you're showing you know the basic principles of the maths, but you can't get full marks for shoving the wrong numbers in it.
I think that is right intuition.
Yeah.
So, because I wrote down all the initial velocity and stuff like that.
Yeah, go on.
Like, obviously we all struggle with this. So is there any, like, exercise that we can do that, like, just has these sorts of questions in it?
Yeah. That's by far one of the hardest things we've done in this course, I reckon. It's harder than, like, moving about.
Okay, look, the answer is yes, and I'll get some for you if you want to revise that. Yeah, Marnie.
I had the formula v equals u plus at.
Yeah.
That was wrong.
That was wrong. Yeah. Now, the impulse here, don't forget, a lot of people when they see the word impulse are immediately going to think that what they need to do is use the formula Ft equals something, right? mv. But what that actually tells you is the impulse is equal to the change in momentum of something, isn't it? Okay, so a lot of people try to work out the force and the time and all that sort of stuff, but all I'm worried about in this equation is I equals the change in momentum of car X. Now, for car X, that means what we're looking at is mx vx minus mx ux. What I'm saying is the final momentum less the initial momentum is the impulse.
But the final momentum equals the initial.
No, it doesn't. The whole momentum for the whole system is the same, but the momentum has changed between the two objects because some of the momentum from that object has been transferred to that object.
Yeah.
Okay? Make sense?
Yeah.
So what you guys have to know is that even though that's the formula, they want you to know if you know what that formula is saying, which is the change in momentum is what the impulse is. So you just have to work out change in momentum, which of course is 6 times, and now the final velocity of that thing was 0.06, wasn't it? Yep,
Yeah.
it tells you that. Minus 6 times, now I've got an opposite direction here, so I'm going to have to put minus 0.25. And when I do that, again, you can put that in your calculator and come up with an answer, which happens to be minus 7.68 Newton seconds. Minus 7.68. It has to do with the fact it's changed direction. So the impulse is acting the opposite direction to its initial velocity, and so the direction must be minus. Okay?
A mathematics might be that to me.
Now, I wish that would stop going blue.
I got C.
Now, the last question says if the collision between two cars lasted 0.03 seconds. Now, the hint in this question that you're not going to use the FT formula is you're not given a time. Because you don't have a time in there, it should ring bells to you when you look at the question and say, well, I don't know time, so using FT is not going to work for me. They must be hinting at something else. And this is part of the skill of reading questions, understanding what information they give you and then what you're going to do with that information. Okay? So this one, they've actually given you a time. They tell you the time that the collision lasts for. And they want to know what average force did Y apply to X. Now, obviously, the impulse is mv. And I can rearrange that to work out force, mv on t. Okay? And then I can work out the change in momentum on car X, and that would tell you what force must be applied to it by car Y. Yep?
I'm just wondering after this, can we do the one about the electric circuit diagram?
Yeah, that's fine. So when you do that, what you end up with is a formula which looks a bit like this. I wrote it out last night, so I'm just going to 6 outside 0.06 minus 0.25 all over the 0.03. And if you do that, you'll find out that there is 3.8 newtons of force applied. Okay.
Is that a minus? What's that third line of the impulse one, sir?
That.
Up one.
Oh, that's just
on the same question. Sorry, third line of the same question.
Third line, second question. That's a minus.
Yeah, minus
times minus 0.025.
Well, that's not right there. Is it?
Yeah, because to find the difference in, you do a subtraction, but that one is going that way. And, sorry, that 0.25 is that way, and 0.6 is that way, so they're in opposite directions. So there has to be a minus sign to show that you're going in opposite directions with your speeds there. Okay? All right, let's rub all that off. Now look, I will freely admit that is one of the harder questions in the paper, so it doesn't totally surprise me. And don't forget, guys, when they write the paper, they don't write the physics paper so that everyone will get 100% in it. That would be foolish and silly, because they want to differentiate between students. So there are going to be questions that they think that everyone should be able to get the mark for. And if they don't get 99.9% of people answering it right, they've misdesigned the test. And then they're going to put a couple of questions in there where only the top 3 or 4% of the populace should get it right. So when you come into the HSC, you are going to find questions which are hard. Okay? And that there, the momentum question here was one of the harder ones in the paper. It's designed for the very top students to really grapple with and get out. So if you struggle with that one, that's not something you should be feeling worried about. That's something that gives you a level to aspire to, so you can work and say, that's the level I need to be able to do to really be a top-notch student. And there was a lot of physics in that question, an awful lot of physics, a lot of understanding. Okay? And that's not bad. Okay. Don't forget, this is going to be up on YouTube and also up in Google, so you can follow it up there. I've actually posted all these. Well, you really don't want to do too many more prelim ones. And these momentum questions typically don't appear in the HSC. You might, if you're unlucky, get one. Okay.
Oh, the first one. I didn't use R equals B equals IR.
Can I get a mark back?
You got the marks you got. Okay, this one I will go through it, even though you want the electricity one first, and then I'll come back to the electricity one, because this is a question which was quite hard, and we were talking about it yesterday and got ourselves a bit muddled. With this,
It doesn't give you direction.
right? There's two ways this wave. There are two ways this wave could be moving. It could be moving that way, or it could be moving that way. And you're actually not told which one of those two circumstances it is. Otherwise, there wouldn't be a maximum possible period for the wave. There'd just be a period for the wave, right? And to give you enough information for you to have to work it out. Now let's imagine that the wave is moving to the right first up. So in the first situation, moving right. What you do know is, this is where you picked me up yesterday, Riley. You were quite correct in picking me up on this, and I want you guys to pick it up. Imagine if it's moving to the right, there is the top of the wave there, the first crest. And sometimes later, that crest has gone from there to there. It's moved a certain distance, hasn't it? Okay? And the distance that has moved is 7 metres to the right. Because you've got a scale, that's at 2, and that one's actually about 9. And if you've got a ruler out, you can actually measure it. It's done to scale.
So that's
Okay.
9. So how's it?
So the thing is, if it's moved 7 metres in that direction, we also know that the wavelength of this wave is from that point to that point, so it's 8 metres long, right? So in that time, it's moved 7 metres, it means it's moved 7/8 of a wavelength in a time period of 0.35 seconds, correct? Now, the time period for one wave to pass, the time it takes for one wave to pass is the period, right? So having got this information, 7/8 of a wave went past in 0.35 of a second. So now if I divide that by 7 and multiply it by 8, I'll work out how long it takes for one wave to go past, won't I? And if you do that, it works out that you end up with a period of 0.4 seconds. Now if it's going left, the wave will have moved from there 1 metre back that way, right? Correct? Because that crest would have gone from there to there, 1 metre. So it's moved 1 metre. So in that time, 1/8 of a wavelength will have moved past in 0.35 seconds. So now what I need to do is multiply that by 8 to find out how long it takes for a whole wave to go past. And if you do that, what you'll find is you'll get a period of 2.8 seconds. That is the largest possible period for this diagram. So what it means is the wave is moving to the left and has a period of 2.8 seconds.
So mine
Okay.
doesn't have a mark.
I should probably have a cross next to it then. It hasn't got a mark there, it means it should be a cross. Now, once you get there, on the back of your page, you would have found that T equals 1 on F. So if you substitute in identifiable thing for F, you should get some marks, but the frequency actually is 1 on 2.8, which equals 0.3571 or something like that. Now there are circumstances in which you could still get marks in that place, even if you didn't get out the first part. All right. Basically, it turns out that the way they would mark it is if you manage to get some sort of identifiable frequency, which was very clear that that was a frequency you intended to be. If you use that frequency in that question, you could still get a mark. Now, where you can't get a mark in the bottom one is if there's 3 or 4 possible frequencies in the top and you just pick one at random and there's no reason that I could pick that you could use it. All right? If you're going to use a frequency, you've got to be clear which one you're using and why. And then the bottom one calculates the speed of the wave. I'm not going to go into it, but any more than say that's just the wave formula, and you can go from there.
Would we be able to do some of the, these short answer questions?
Yep.
Like stuff that you were saying?
Yeah, I will, but the first thing you wanted me to do was go back over the electricity one.
I realised where I went wrong there. Biggest brain fart ever.
I had a brain fart field biology. I mixed up water and water. That's the first one I'm going to dump that.
Now, I reckon for you guys, that is actually conceptually probably the hardest question. Now, I remember going through a question like this with you guys, saying, this is difficult. Remember, a wave could go both ways, and talking about it, but it's conceptually really hard. And in a test, this is the sort of thing that goes out your head.
2 questions, that one and the impulse one.
I didn't even realise it's the way.
Yeah, neither. I just went, oh, yeah, it's got
I had a pretty good guess. I had 1/6.
You got one on that one.
What was really disappointing with that one was that someone, I don't know how they did it, wrote down an answer for one question in there. It was completely random and they got the right answer.
Which one? This one?
No, the last one, I think it was. There is one, someone who picked up 1 mark for one of those things because they just randomly happened to write down an answer which was right. If you just write the number down and it's right, I have to give you the mark, even though it's completely random. I wasn't sure which one it was for.
56.34.
Yeah, that's it. You were the one. It's just a random guess and it was right. Hmm. There's another one, someone else did it too. There's another one that was completely random. Someone put 0.35 down for an answer. I forget which one it was, and they got 1 mark for it because it was right.
What did you get? 21.
What question was it?
Yeah, so I put down 0.35.
Yeah, completely random.
No, I didn't guess it. That's sort of,
Well,
0.35 because that was the time.
It was an educated guess.
That's why I put down 0.35
okay.
because it was the time.
This field diagram, the one about the
I'll come to that.
It was actually a kid.
There are some tricks to getting that one right.
I got 4 marks, so I just completely guessed, oh yeah, this one's stronger. Oh, I put the X in the middle there. So 3 marks.
Okay, guys, concentrate on the one we're concentrating on because this is important. Okay, as I alluded to yesterday, the trick with these things is to work out what is in series and what is in parallel. And I had a brain fade yesterday and started to go wrong, so I'll go right with it today. Okay, where things are in parallel is where the current has to split. Where things are in series is where the current stays in a continuous stream, right? So essentially, you've got a couple of parallel resistors, and you've got a resistor sitting out on its own. Now, the first thing you can do very simply is by using Ohm's law, you can work out your total resistance in the circuit because you know that V total is going to equal I total, R total. And so therefore R total, of course, is going to be V total, which is 42 volts. And I'm not going to put the V sign in, all over 6 amps, which is going to be, of course, 7 ohms all up. Now that's a pretty important first up step. Second thing then is you want to work out depending on which way you go about it. I'm going to determine the value of the resistance in R, just because that's probably the hardest question there. And I will do it. Yep. Just trying to find my notes about what I did here. Okay, so let's do B first up. The first thing is you want to work out what your resistance is through here. Now, you've got a 5 ohm resistor there, right? And you've got a total of 7 ohms around the whole circuit. Now, when that becomes a virtually, when you treat that as a single black box resistor, that puts in the series, doesn't it? Yeah. So that means that you're going to start off with your R total is going to equal 7 minus 5. So through this thing here,
it's not plus. I thought they add up. So.
None. They do. Each of these individual things must add up to the total of 7 across the whole circuit.
Oh, there's 7. Oh,
Yep.
was that given, was it?
No, I've worked it out by using the...
Oh, yeah, did you?
Okay. So now I know that my R total for this black box resistor is going to be 2 ohms across the whole thing. Okay. Now, because they're in parallel, I'm going to need to use the parallel formula for resistors.
1 over 2.
So 1 over RT, yep, equals 1 over R1 plus 1 over R2. So therefore, as was alluded to, 1 over 2 is going to equal 1 over 3 plus 1 over R. So that means 1 over R is going to equal 1 over 2 minus 1 over 3. Now, you obviously have to work in sixths. So you're going to end up with 3 sixths minus 2 sixths, which is going to equal 1 sixth. That means R is going to equal 6. wasn't it? Should be. It should be in there. That's just the standard one that they always give with these exams. So. Now, the reason I did that first is that now what I know is that through this junction, 6 ohms must flow. Some of it must go that way, some of it must go that way, and now I can use my ratios, can't I? So that I know that my ratio is going to be 6:3 will be is going to be the ratio of the current through those two things. So through here, 1/3 will flow. Through there, 2/3 will flow. So therefore, the current through there, as the ratio is 1/3 to 2/3, 3 ohm resistor must have 4 amps through it. And sometimes with these questions, it's just a matter of knowing, not following the order they're in, but knowing which one to do first.
I feel really bad because I spent like a couple of hours doing those sort of questions over and over, and I should have got it right, but then I just made a big hours.
Yeah.
Yeah, not for me. Practice.
Now, the good thing is the energy one, the first thing you need for your 2 marks is essentially put this, right? And put some meaningful numbers in. There is, however, a bit of a trick to it. That's 2 minutes, which means that when you put it in, your voltage is going to be 42, your current is going to be 6, and your time is going to be 120, not 2.
So if you had to put just a voltage and a current, if you had to put in 120 seconds, you would have gotten
2 marks. But everyone who put in, most people put 42, 6 and 2, which gives you a mark.
I got 42.3 because depending on the other one, and then I knew it had to be kilowatt hours.
Marnie, what's wrong?
I had this formula
I'll come and have a look. No, well look, if you have the wrong numbers in it, and I can identify where those numbers came from and they make sense, you get marks. If they just are numbers I can't identify where you got them from, yeah, but the marker has to be able to see where they got them from. But I'll come and have a look, Marnie, and see if there's an issue there. But typically, you have to be really clear, even if you draw an arrow back to where you got those numbers from or something, or even put stars. It helps the examiner if they know where you get your numbers from. Yeah, quite. You can just put, 68 from answer from A or something next to it, or a star or something. Or you can put down your data at the side, from A, V equals 68, just so they know, particularly if you know you're not certain above, so that the examiner actually knows where you're getting your numbers out of. Because if they can't identify it, you're not going to get any mark. If they can see that you have to use something from above, you got it wrong, and you put it in, it's not a problem. If you just write the formula in a 2 mark, you're not going to get many marks for it.
So the prelim first course, are we competing with the year above us for that as well?
No.
No.
It's a really peculiar setup this year, but no, you're not. All right, now you wanted to, there's one other question people wanted to really look at.
Would you be able to go through just list a couple of things we need to say in these short answer questions?
Yep.
Actually, would we be able to do that next lesson if that was about to go?
Yep. Oh, look, electric field around these two, guys. A couple of things to pick up. Please look carefully when you do these things, because first thing to notice is that's plus, that's plus. They're both positive charges. All right? That's the first important thing to notice. So you can't just assume that they're positive and negative. Second thing, twice as big as that one. So the way they represent that is obviously what you're taught to do is you draw a line like that, you draw a line like that, you'll have a series of lines which sort of curve out like this. Something rough like that, that's good enough. For this one, it's also going to do something similar.
You mean
Now, I was about to come to that. So what you want to do, draw them in like that, and then come back to the first one and put double the number of lines in. Okay. Then obviously, X marks the spot. Into question
I
2.
completely guessed that X one, and I got it.
Yep.
You know, there's a mark because like I was thinking magnets and my lines when they went out around.
You notice it says this. Charges,
Yeah.
electric field.
But,
If you mention magnets,
no, I didn't actually mention magnets.
you did in the bottom question.
Oh, I did.
You did, north and south.
Oh, yeah, I did.
Hmm.
Yeah. But like, how they looped around, is that wrong? Like, they should be going around.
I gave you, what did I give you?
2.
Yeah, look, I accepted that you showed different strengths of fields and you showed, and I was looking for the field line relationship in the middle.
Yeah.
I kind of ignored anything else either side. Okay, so strictly you should have that. The looping, if you didn't actually see, they'd probably go funny colours at you. So it's that's strictly 2 marks, but I go, I've been,
That's a 3-mark question.
oh sorry, that's 3 marks, yeah. You're looping around, that's what it was,
So
yeah.
my looping around is
Yeah, yeah, because you can't get charge going to charge in a field. No, I've got them. All done. Very good. Thank you. Yep. And we've got a few other little things to do.
Would you get early?
I'd love to get that book back. Thank you. Yeah, well, I know you've done it. One other person's done it, so.
I want that in 3 days.
Oh, it's doing kind of tough. If I had a car, I would have
Thanks, Ed.
That's all right. Money. Show me that.
I don't know. It's
This is why. What have you marked that at?
volts.
Volts.
Should be ohms.
And that's called a contradiction.
What's that mean?
It means that you called it current there and you put it down as volts there. And they get very fussy about that stuff.
Oh, do they?
Yeah.
Oh, okay.
You just can't do that.
Yeah. That's right.
Just to clear for a second.